So thank you very much, first of all, to Estia for inviting me to this very interesting meeting. In my presentation, I will focus on some strategies that we have used in the past in PTB R&D projects related to how to recycle what we call smart textile wastes. That means textile matter that is coming from this kind of specific products. First of all, what is ITEX? ITEX is an R&D center. We are located in Spain, in Alcoy, very close to Alicante. And we are related to the textile industry and also to the cosmetic one. Our main activities to carry out R&D projects, but we are also offering some lab services to companies in order to properly characterize all the products, and we are also supporting them in terms of training, but this kind of training is more focused on new technologies and all the trending topics in terms of R&D. On the screen, you can see some figures on KPI related to our institute and the photo of the new facilities that we started 1.5 years ago. Today, I would like to talk to you about. Oh, sorry, there is some problem with the presentation. Yeah. You can see on the screen some figures about the different categories of the textile wastes that are generated nowadays in Europe. This is the result from McKinsey study that was performed 3 years ago, more or less. And it's quite interesting to see that nowadays there are no possibilities in terms of recycling of textiles. I have to explain a little bit better. If you have a look on the figure of the left, you can pay attention on the low percentage of textile materials that nowadays is recycling under the fiber to fiber strategy. Nowadays is more or less than 1%. And of course, it is expected to increase this percentage in the next few years. But as far as I know, at least in Spain, this percentage nowadays is very, very low. So there is a lot of work to do. And for sure, fiber to fiber recycling technologies are more or less well known. I would like to focus in this presentation in some R&D activities that we have been performed a couple of years ago, but we were more focused on this kind of textile wastes that cannot be considered in fiber to fiber recycling strategies. So it means that we are now more or less focusing on this kind of wastes that are available to recycling, but no solid strategy that is available nowadays. We wanted to focus on textile wastes for two main reasons. The first one, it is because we understand that in technical textiles markets, there is a high interest in incorporating electronic items and all these kind of advanced sensors that can be used in sports, defense, and so on. The second reason that we wanted to explore in this project is that we understand that this kind of textile wastes are the most complex in terms of recyclability. So they are including metallic threads, electronic connections. Some of them are also laminated, coated, or even printed. And you can find a huge variety of materials, not only textiles, but also zipper, buttons, circuits, and so on. So they are going to require, according to us, an alternative mechanical reading process. In this sense, in ITEX, we started to explore an alternative reading process that can be seen on the screen. First of all, we are performing the reading process. And after that, we are able to use a magnetic conveyor belt in order to remove the ferrous pollutants that are included in the clothes. After that, we are using a second unit that is called an eddy current separator, that it is applying an electromagnetic field on the wastes, so we are able to split the textile fibers from the non-ferrous metals pollutants. After that, we've got a second conveyor belt, and finally the cutting machine, where we are able to adjust or to optimize the final length or the final average particle size of the material that we are able to obtain. Depending on the density of the materials, our pilot plant is able to split between high density and low density materials. But in this R&D project, we noticed that that density differences are not so high in order to properly implement this final unit in the pilot plant. On the screen, you can see some examples of the ferrous metals pollutants that were removed from the smart clothing that was under research in this project. It's a mixture of metallic threads, textiles, and plastics. This is the second kind of wastage that was generated in this reading process. This is the non-ferrous metals fraction. And finally, this is the type of very short fiber or even particles that we are able to obtain at the end of the reading process. So the proof of concept was, according to us, quite satisfying, because we were able to demonstrate that by using the most conventional shredding technologies that are available for plastics and some other kind of products, but in this case it was used for smart textile valorization, it is possible to remove all the metallic pollutants, combining ferrous and non-ferrous elements. The final product that we are able to obtain in this process is like a mixture of fabrics and plastics. We obtain very, very short fibers, because we are not thinking in a fiber-to-fiber strategy. In fact, I will show you later on what can be done with this kind of new raw material. And as I mentioned before, the air separation system was not valid in order to remove the plastic pollutants that are included in the fiber fraction. We know that it could be used some other technologies like vibration screen and densimetric table, but unfortunately this kind of technology is not available in our pilot plant. So we decided to go ahead with the combination of plastics and very short fiber in order to try to obtain good quality non-woven or even composites derived from them. So this is the next step of the project. In this case, due to we are obtaining a very short fibers from the reading process, we decided to employ wet lath technology in order to carry out the manufacturing of the non-woven. This is a quite specific technology for non-woven manufacturing that is taking profit from fibers or even particles with a very, very short length or diameters. What we are making in this process is to, first of all, to carry out a dispersion of the fibers in a water tank. And after that, with a pump system, we are generating a feeding of water and fibers on a conveyor belt. In these systems, we are applying vacuum, so we are able to remove and to recover most of the water. And after that, the non-woven is going through a heating system where we are able to provide good mechanical properties to the material. This technology is able to work with carbon, aramide, glass, natural fibers, The only limitations is that the fiber can't be soluble in water. And we can find different applications for this kind of nonwovens. So you can see on the screen, for instance, composites, defense, filtration, and why not technical clothing. I will show you a very short video about the technology and our pilot plan. As I mentioned before, we are taking profit from this technology because it is a paper-based technology, so it means that it was conceived to work with very short fibers. And the kind of materials that we are able to obtain at the end of the process are quite similar to a thick paper. This is the phase of dispersion of fibers in a water tank. In this process, we are considering the possibility of mixing wastes with some other kind of technical fibers if it was required. And after that, the pump system is going to create this kind of non-woven layer on the conveyor belt. And finally, we go ahead with thermal treatment in order to improve the mechanical properties of the non-wovens that has been developed. After this process, what we were able to obtain is, as I mentioned before, a very thick paper. This is the grammage of the material, 300. And in this case, we consider the possibility to make a mixture. So we are combining 75% of what we call smart textile wastes and 25% of bicomponent fiber. This is virgin fiber that is helping us in order to improve the mechanical properties in the non-woven. Why? Because these kind of fibers, they are melting and they are generating this kind of glue system in the non-woven in the phase of drying after the wettest stage. On the right of your screen, you can see some images of the plastic pollutants that were included in the non-woven. These were the plastic particles that were generated during the redding process. Of course, this material by itself, it can be considered a final product. So we decided to carry out a finishing stage on the non-woven. And in this sense, we decided to use a double flat bed lamination technology. This is another pilot plan that is available in our institute. So in this case, we are applying high pressure and high temperature on the non-woven in a continuous manner. So we are trying to improve the mechanical properties by melting a little bit more the bicomponent fiber that is included in the non-woven, and we wanted to get a more homogeneous surface on the final material. Which is the result? So we were able to properly carry out the finishing stage of the non-woven, and we noticed that the technical parameters that were considered in this finishing process were also of interest in terms of melting the plastic pollutant. So at the end, we were able to obtain a very homogeneous product that we can consider that it could be used in different scenario application. As you can see on the screen, the processing temperature in the lamination line, it was 180 degrees and 7 bars in terms of pressure. So at the end of the project, we were very satisfied because we were able to demonstrate that it is possible to remove most of the metallic pollutants in the textile wastes that are coming from what we call smart textiles it is also possible to obtain short fibers. In our case, they were polluted with plastic elements, but at the end of the project, we were also able to carry out a strategy that demonstrated that these kind of pollutants um, are not a problem. We are very happy because the technical non-governance that we have been able to obtain, it could be also used um, for many applications like composites, like multi-layer materials, thermal insulation, acoustic insulation, thermoforming products, and so on. And we were also able to demonstrate that this strategy is also valid for multi-composition textile products like smart textiles, but also it could be considered for some other technical products like materials coming from defense, from sports, and so on. So thank you very much for your attention. This is what I wanted to share with you. This is just an example of the kind of projects that we are developing nowadays in ITEX. Some of them, of course, are related to circular economy, and some others are for another topics. Thank you very much. And if you have any question for me, I will be very happy to attend you.